morning, good afternoon, good evening, whatever the case may be. We are back and better than ever. And is there a better jam than the spirit of the radio by the legendary rock band Rush? I don't think so. This is the spirit of HL Mathematics. Begin the day with some HL Mathematics, that's what I say. Let's get to it, shall we? I could listen to that through this whole tape, but we'll quiet it down a bit. So, what's going on here? We got an electricity station located right there. That picture is a little deceiving, but we have to assume it's located right here, 200 meters away from the lighthouse. Let's see. The angle between the coastline and the line joining the lighthouse with the electricity is 60 degrees. Cable needs to be laid connecting the lighthouse to the electricity station. This is the trickiest part of the problem. If you ask me, it is decided to lay the cable in a straight line to the coast and then along the coast to the electricity station. By straight line, I mean, all lines are straight, but what they mean is at a right angle to the coast. Well, no, I guess it's not necessarily a right angle, but straight line kind of confused me. The length of cable along the coastline is X meters, so once the cable hits the coastline, it's going to go over to the electricity station, and that length is X meters. The information is illustrated in the diagram below. Okay. The cost of laying the cable along the seabed is $80 per square meter, so this is 80 bucks here, and $20 along the coast, so this is going to cost us $20, the X there. Find in terms of X an expression for the cost of laying the cable. Well, so our cost is here and here, so I'm going to label this Y, and I think you would agree that our cost is equal to 80Y plus 20x, but this has to be in terms of x, so we have to get y in terms of x. So easy. Our good friend the cosine rule tells us that y squared is going to equal 200 squared plus x squared minus 2 times 200 times x times the cosine of 60 degrees, which you immediately know is 1/2. If you don't, I don't want to know about it. So y squared is equal to 40,000 plus x squared minus 2 times 100 times 1/2. So that is minus 200 x, which means that y is equal to the square root of all of that. So that's for x squared minus 200x plus 40,000. Okay, so that's just the length of y. So the cost is going to be equal to 80 times that times the square root of x squared minus 200x plus 40,000. This is a dream problem. It's so easy, right? And then, of course, plus the cost of laying the cable along the beach. So that would be plus 20x. So we have done part A. Part B is more of a test on, do you know how to use your calculator? Find the value of x to the nearest meter such that this cost is minimized. This is a paper 2. If you try and take the derivative of this, set it equal to 0, and solve, you have just wasted a good portion of your life. Go to the calculator and graph it. So we are going to do 80 times the square root of x squared minus 200x plus 40,000, yes, and then make sure you get out of the square root before you add the 20x. Check your function, looks good to me. Boom, chugga-lugga. Oh no, it doesn't come up on my little window, so I'm going to have to try my scale. But before you try your scale, you should, try a couple things to see, how to change your window. Clearly, we're going to, or how to set your scale, where to set your scale. Clearly, we're going to be interested in quadrant 1 because we're going to have a positive value of x for the cable. But here's what you can do. You can add a page, and this is why you should always work in a document. And we're going to add a calculator. And we can get some values, like the function here, tab, let me go up. It's f1 of x, right there, f1 of x. So if I go over to my calculator page and I type f1 of, I don't know, say 2. Well, it tells me at 2, look at that. The value of the function is 15,960. So I got to have a huge y-axis, okay? And we're talking about hundreds of feet here, so that gives you a clue as to what you want your x-axis to be. So let's go to Menu, Window Zoom, Window Settings. So I'm going to go ahead and, I don't know, maybe -20 to 200 with a scale of 20 would be good. And that was, what, 15,000? So I think I'm going to go like -2,000 for a min. That's 20,000. -2,000 to maybe 20,000 for a max. So I can get a nice pick. And maybe 2,000 as my scale. Then it won't be all junked up by tick marks. Ah, there she is. Not bad. And you can see a minimum. I'm just crazy. I want to see a better picture. I'm going to change that to 30. I double clicked in there. I don't know. Well, that wasn't all that much better. But anyway, clearly the minimum occurs there. So now all I have to do is Menu, Analyze Graph, Minimum, go to the left of the minimum, go to the right, stand up, sit down, fight, fight, fight. And boys and girls, we have got ourselves an answer, which is 55.3, seemingly so. So what we're going to do is we're going to sketch a graph, boom, 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 right? And we're going to go like this, and we're going to say a minimum is at 55.3, and what was this? Y coordinate, 1.54 times 10 to the fourth, so that's going to be, what, 15,400? Which really isn't important. So what's the question? X equal to 55. Mr. Becker, Mr. Becker, Mr. Becker, that's not 3 sig figs. You're yelling all the time. Read the question. It's to the nearest meter. Don't lose a point just because you didn't read. So it would be X equal to 55. That was awesome. It's very exciting. The only thing more exciting might be, well, is Rush. Nice! I have done all the damage I can do, so I am